for this. And we used to add, subtract, and multiply matrices last time. So today we're going to discuss idea of division of matrices. That's what we, I guess, still need to get from this little section, which is nice and short, but it's still something that, well, takes a little time. So anyways, the idea of dividing numbers, let's say if you divide 2 by 3, you get like 2/3, right? Is here. And what does this really bring us with? Well, first of all, you can find so-called inverse of the number. So for example, if you start to divide number 2 by itself, you're going to get 1, right? Or you could turn this into multiplication and say you're multiplying by the reciprocal of second number by 1/2. That's how you get 1. And division then could be turned into multiplication, and 1, or so-called unit, with respect to multiplication is what we are working with. So with matrices, the units gonna be matrices that look like so-called diagonal ones. So on the diagonal, we see 2 numbers, 1 and 2 zeros. Or if we look at the bigger size 3 by 3 matrix, also diagonal will consist of 1s and everything else will be just zeros. And that's what is being utilized when we are thinking about those units. In other words, if you take any number, let's say 5, and times it by that unit, nothing is going to change. So you produce the same exact number 5. And that's the idea of multiplying by these unit matrices. So we are able to actually, well, I guess not to change the original matrix. What I'm going to do is take an exercise and try to refresh how we used to multiply, as well as just practice some more of these multiplications and see that indeed those diagonal matrices or unit matrices are the ones that pretty useful. So I can try an exercise with multiplying by that unit matrix. So let's say if I take a problem number 61 and, well, not do the actual exercise, but try to multiply it by that unit first, and then we'll see what else we can do about this. So in exercise 61, if I multiply this given matrix by that diagonal with 2 1s and everything else equal to 0, the idea is we're not going to change that matrix, so it's going to stay identical. So the question is that right? Let us double check. And to recall how we used to deal with multiplying matrices, we always used the row, the first, and multiplied by the column of the second. So if this matrix is size 2 by 2, and the second matrix is also that same size 2 by 2, since these two numbers are the same, then what remains is 2 here for number of rows and another 2 for number of columns. In other words, we get same 2 by 2 size matrix. So I can prepare it and we can try to multiply. So there are 2 rows and 2 columns here. And the way multiplication goes is multiplying corresponding entries, right, of the row by corresponding entries of the column. In other words, I multiply 4 by 1 here and add it with a product of 2 by 0, like that. And continue same thing, but with the second column of matrix 2. So I'm gonna multiply now these numbers like that and get on the row 1, but the column number 2, the result, which is going to be 4 times 0 plus 2 times 1, right? And you can see already that these times 0 mean nothing, and then we have actually 4 preserved as well as 2, so nothing changed in the first row. And then analogous procedure I'm going to perform with my second row. So I'm gonna again take the row and multiply it as usual by the column. So the 2 will go with 0 and 1 will go with 1. I know this is not a very intuitive procedure. It's very, I guess, artificial, but we just want to see it to be able to get used to it. So it looks like here again, the first product disappeared because of this 0, and we have only 1 left, and that's just what we needed. And this is great. So now we're gonna finish up with this and put it multiplied by the first column of the second matrix. And we already noticed that it doesn't really matter in which order you perform these term of the matrix finding process. So here I go 2 times 1 plus 1 times 0, because they're not really related to each other. So that disappears because it's 0, and all we left with is 2, and that's exactly our goal. So turns out multiplying by that so-called unit matrix, unit, it's just like a number 1 analog, just like multiplying by 1, nothing will change. Well, why is this so important to deal with these unit matrices? And it turns out it's for finding this so-called inverses. So if I had number 2, then it's reciprocal, or people say inverse, so that 2 and 2 cancel, will be 1. So when you are multiplying, it's not hard to find the inverse. All you have to do is think about flipping that number, and that way, right away, you produce the answer. And of course, with matrices, it's not that straightforward. It's always going to be something a little different and a little bit more complicated looking. So the inverse people call as a to the power of -1, just like 1/2. You could have treated as if it was a 2 raised to the power of -1. So it's kind of analogous, right? So then you flip that 2, you get 1/2, and that's similarity here. And the result should be inverse. So instead of number 1, I put that inverse matrix, that identity matrix, which is 1, 0, 0, 1. And that's how this supposed to be set up. And it turns out there is a very important fact they discuss, that to have the inverse, this matrix may not have inverse. The determinant of this matrix, so if I look at the determinant of that matrix 4, 2, 2, 1, remember, determinant does not have this brackets. Determinant just has bars in it. So determinant is number that we produce by doing this little multiplications across. So if I multiply 4 by 1 and subtract from it product of 2 times 2, what I'm going to get is number 0. And if determinant is 0, then we have no inverse, just like for the numbers that we are trying to find the reciprocals of. If you try 0, so the question is, what should I multiply this by in order to get 1? And since it's 0, well, you cannot just write it as 1 over 0 because it's not defined. And that's kind of analogous to what we just produced here. So determinant cannot be 0 because if you have 0 multiplied by what in order to produce this identity? Well, the inverse does not exist. So we say there's no inverse. And that's what they want me to find in this group of exercises, just to see if determinants are zeros or not. So I can try another one like number 64. So here I can multiply -3 by 0, right? And then subtract from it product of 4 and 0. And when I do this, the result is 0. And again, it's no inverse. In other words, they telling you here that all of these matrices have their determinants equal to 0. So I can try one more, like number 65 exercise. I need some room for that. I'll share the board with you. So I was thinking maybe today I will ask you to find the determinant of some matrix, and maybe that could be a good exercise for the midterm exam. Because I already started to think about midterm, which is going to be next week at the very end. On Friday next week will be midterm. And goal is to get you prepared for this, and you already know what exercise is going to look like to find determinant. Maybe I will ask you not for a very big one, like 3 by 3, maybe a little bit too much for some people. So maybe I'll ask you for something nicer than that. Maybe I'll ask 3 by 3, but I'll put lots of zeros, so it'd be much easier to operate with. So anyways, first row, another is 1 minus 4, and then -2. And finally, third row is 1, 2, and 5. Okay. So for this matrix, I put just bars, so it'd be a determinant. And we already have a hint that this is supposed to be equal to 0, which is nice to realize. So if I use my, say, first row, and then start with selecting first column, so I'm going to have -3, which is here, right? Multiplied by whatever is left, which is in the lower right corner, -4, -2, 2 and 5. The next number now will come with a minus sign. Remember, signs plus, minus, plus. So we'll have to change the sign here to -1. And now I'm gonna disregard that first column, but take second column. So now I'm dealing with this number 1. So what's left? Well, looks like 2 1s in the first column, then -2 and 5 for the second. Remember, this is the way we broke down those bigger matrices to the nicer ones. And then finally, there'll be next entry of my first row. That entry is -1. And then I will utilize whatever is left over here. So that'd be, again, 2 1s, and then -4 and 2. So let us carefully calculate these determinants. So I need to go across. This will be positive. So it'll be -4 times 5. And then I have another cross product, which is going to be with a minus sign. So it'll be like -2 and -2. Okay. So similarly, I will put another determinant here, which is 1, 5 with a plus, and then subtract 1 times -2. So if you do it a few times, I'm sure you will start to get used to it. So 1, 2 is here across this main diagonal, and the other diagonal is subtract 1 times -4. Okay, so what are these results? Here we have a -20 plus 4, so it's -16, right? Please double check. And then 5 plus 2 is 7, looks like. And finally, we're going to have 2 plus 4, which is 6. Okay, so those are little determinants, and whatever numbers were in front, I will copy them. So -3 times first, the other is -1, right, times the second, and finally the last is -1 again times third. So now the weak spot, it's the one I was making mistakes last time, right? So, but the good thing is we fixed it, remember? So subtract 7 and then subtract 6. So you're subtracting 13 from 48, and you get something like not a 0. When you say, Alex, what's going on? What is wrong here? Did you mess up again, or what is happening here? Well, let me read the question. Do they all have to be 0? Show that each matrix has no inverse. And I got a matrix that 1 minus 4 and minus, is that 7 or that's 2? I think it's -7. I think I made the mistake writing this down because I think it's -7, and that's what I think I went incorrectly with. Well, actually, it's good because I shown that this matrix does have inverse. So in other words, this one is supposed to be not -2, but -7. Do you see that? So I miswrote the exercise. So it's not 65. I can say it's like 65 with a star. So this way we can better see what is going on. So if I share back my page, right? So you can see that 65 actually had -7. I, for some reason, put -2. So, well, then this matrix does have inverse. It has inverse because its determinant is not 0. And that's pretty interesting. And maybe I will show you how to find that inverse. Why don't we try to find the inverse for that matrix? I will do it just once. It's a very specific procedure because I don't think you're gonna use it anywhere in calculus. But since it's already being discussed here, they say find the inverse in the next group of exercises. They say using graphing utility. I can find it for you by hand, so you will see that why I don't really get into finding the inverses. But to you, it'd be a good idea that you sometime tonight or tomorrow try to replace that number -2 with a -7, and actually to see that the result is going to be 0, because that way you will actually show that there is no inverse. But now I will take that matrix again and actually the one that I produced by accident, and I will produce the inverse for you. So you will see the actual process. Let me go back to this nice page and try to copy this matrix on the next page, because I'm definitely going to need a lot of room here. So once again, the matrix is -3 1 and -1, and also 1, -4. And now if I put -7, there'll be no inverse. So I'll put -2. That's what I copied by accident, right? And then 1, 2, and 5. It's good that I did it because this way you can actually try to do analogous the actual 65 on your own. So if this is called matrix A, the question is, what's the inverse of that matrix? What's the A inverse? So let me find it using the special procedure of triangulation. What does that mean? Well, I'm going to make a triangle. In other words, I'm going to produce a bunch of zeros instead of matrix A. And the way it should be done, I'm going to attach identity matrix, which is in the case of 3 by 3 will look like that. So main diagonal is only designed from numbers 1, but everything else is 0. And then I'm going to have to do special row operations in order to produce that identity matrix, but here on the left. So how can I do that? Well, first of all, what I can do is produce number 1 in the upper corner here. So my goal will look like that. 1 on the top and 2 zeros on the bottom. So instead of my first column, and then similar process to what we had when we solved systems of equations, remember? So we'll put row 1 here that I will divide by -3. And that way, instead of number -3, I will get -3 or -3, which is 1. In other words, I divide it by itself. In other words, I have to divide by this -3 each entry in this row, as well as on the right side in the so-called augmented matrix. The only good thing is that when you have zeros, when you divide them by -3, it means really nothing, they still stay as zeros. And what I do now is write in my first row -1/3, +1/3, because negative divided by negative is positive. And then on the right side, it will be -1/3, 0, and 0. And I already have a good start because I produced 1 that I really needed to start. So now the question is, how can I get the rest? So I'm going to clear this mess a little bit, because now I'm going to need to work with this. Well, the right side. Okay, I'll also clear it here. Make it nicer. So now I need to produce 0. And the way we produce 0, we have to get somewhere -1. So to get -1, remember, we always use the first row for that. I'm going to get division by 3. Because if I divide -3 by 3 and collect it with what's down below, I will get that 0 that I need, because I will have that 1 and -1 that will cancel each other. So, as usual, we have to do it with the whole row or whole equation. So I divide everything by 3, just like that, and collect these terms with what we have down below. And now you see that fractions will appear. Like, for example, here I'll have -4 and 1/3. So how many third is that? Well, it's like 4/3. And if I divide and multiply by 3, nothing will change, right? So it'll be -12/3, which is 4 with negative sign. So -12 plus 1 is going to be -11 of these thirds. You see, the process is getting a little bit tedious. Analogously with what's down below here, we have a 3 multiply and divide, so it'll be minus 6 thirds minus 1/3, which is negative 7 thirds. And that's why I'm saying that this procedure, I'm not really trying to get into very deeply because it's involved heavy arithmetic. When you say, what if I use a calculator? You can do that, but it'll be 0.6666 because those are thirds, right? That's why if you like, you can do that. So 1 and 0, I collect, I put 1. And finally 0 and 0, that's my favorite, it will be 0. And we're producing a little by little the goal, which is going to be a identity matrix. Remember what we're trying to do here. It's always a good idea to remember what we're after. So this is going to be our goal. So we need to have first column that looks like that. Then we're going to do this with a second column and then with a third column. And inverse matrix that we're looking for will be produced here on the right. Turns out that's the procedure. So when I get my goal here on the left, which is going to be diagonal.
Wait, so, excuse me?
Yes, I'm waiting.
Okay,
Wait.
so basically to get the negative 11/3, what you did was you multiplied negative 4 times 3, which gave you 12, and then you subtracted that from the one on the top from 1/3.
Yeah, that's how we always do that. Our goal is to produce 1. And we produce from that 1, 0. So I produce 0 by dividing by 3 and adding. So now I have to divide by 3 and add it with what's down below everywhere. I pay the price for that 0. And the same thing I'm going to do with the next one, pay the price for the next 0 produced. And looks like it's also going to be negative 1 if I divide minus 3 by 3. But now it will be added with 1 down below. And so kind of similar. And that'd be the way to go. So we do arithmetic. That's basically what it is. So if I collect now,
Thank you.
We'll get 0. And now we're paying the price. Now we have these thirds everywhere. So from these whole numbers, I'll have to be producing fractions with denominators 3. As you noticed, you multiply and divide by 3. So nothing changes, but now we have 6 thirds and 1/3 on the top that will give us 7 of these thirds. Well, just need to, I guess, mess with fractions. So do same thing with 5. So it'll be 15 thirds minus 1/3, which is 14 thirds. Just like that. And we continue with the rest, and the rest is not going to change much because we'll just get a 1/3 in here in the start position. We get a 0 divided by 3, 0 with 0, that's another 0. And finally, just number 1 will stay because 0 over 3 is 0 plus 1 is just number 1. So I got a little bit better. And now my goal is to produce the second column. And producing the second column turns out always starts with 1 that we need, just like we had 1 in the beginning of first. Now we're going to need 1 in the middle of the second. So I need to turn this 11 thirds into number 1. And how do I do that? Well, I use its reciprocal. So I need to multiply it by negative 3 over 11. Not sure if I can fit it here. It's kind of not enough room, but the idea is if you multiply the number by its reciprocal, your goal, number 1, will be produced. So I'm going to continue here on the right side. Looks like my first row is already what I needed, because I produced 30 zeros here. So I'm just gonna actually, I need to hold on with that. Let me hold on with that. I just need to leave it alone and gonna start to work with the second row. So my second row is a goal, 0, 1, 0, right? That's what we actually need. So that's 0, 1, 0. I'm gonna need to have, instead of my equation number 2, but first of all, I have to, so that number 1 by produced by multiplying with a reciprocal. So that's number 1 here. Well, I'll have to multiply by that reciprocal each term. So 0 will stay. See, Alex, where you see that's 1. Yeah. But next to it will be 7/11, isn't it? 7/11. That's my next piece. Okay, so I produced what I needed, and on the right side, we continue, so we cancel the 3's, right? So it'll be -1/11, and number 1 is my favorite for multiplying. It'd be -3/11 times 1 is the same thing, and finally, times 0 will give us a 0. Again, what we're doing is we little by little producing our inverse matrix here, but it's not done yet. It will be on the right side when we get that goal as these positions. But we're working towards it a little by little. So then what? Then I have to put 0 on the top and 0 on the bottom. So how can I do that? Well, let's say Alex just write 0 and that's it. Yes, but
Wait, where'd you get the -1/11, -3?
so I multiply by -3/11 each term of my equation. If I want, I can put a little mess here. See, if I multiply right side by 3/11, I must multiply the left side. So both sides of equation. So if I multiply the 3 and 3 cancel, you get -1/11. It's good to double check. And then -3/11, that's supposed to be times 1 is -3/11. And finally, times 0, I get 0. So I multiply every single term by that -3/11 because I needed that number 1. So instead of that 11/3, I had to produce 1 by multiplying it by its reciprocal. So I just flipped it. And now my goal will be to produce 0 on the top and 0 on the bottom. So I will be working now with the row number 2 and row number 1. So that -1/3 will be killed if I add it with 1/3. So my goal is how to get 1/3. So with -1/3, it'll disappear. So if I have -1/3, I need to add it with +1/3. But I don't have 1/3 right now. What I have there is -11/3. Right? So how do I get +1/3? Well, first of all, I need to multiply it by something negative. So negative and negative will be bringing me where I need. Also, I'm going to need to have 11 in denominator, so there'll be no 11. And second, I need to have 9 on the top. So when I, actually not 9, I need to have just 1 on the top, because that way I will have 11 and 11 cancel, and then 1/3 is exactly what I need. So my goal is -1/11. You see, heavy fractions. Well, anyways, -1/11. is what I'm gonna have to multiply by every term here as well as there on the right side. So I produce 0 in that position. In what position? Up here. In other words, I'm killing this one. I need 1/3. So 1/11 and 11/3. 11 and 11 cancel, you get 1/3 and you got 0, and that feels good. And notice that you already have 1 that is not going to be touched, because 1 and 0, when you multiply this by 0, you'll still get 1. But now it'd be a little bit heavier here on the right side, because it's 1/11, right? With negative sign, I have to put together as with 1/3. So I can write it down here, 1/3. And then negative and negative will be positive. And what I have is 7 over 3 times 11, 33. Well, whatever it is, I'm gonna just get this times 11 on the top and 11 on the bottom. That doesn't change it. The goal is to get same exact denominator, 33. And we have here 11 and 7, which is 18. 18 over 33 is what I have to put here. Okay. You can double check if you want. Again, not gonna ask you to do this on the tests, but if you could follow this exercise, I'm sure you will be feeling very good if you decide to take linear algebra class. That's what we're doing in that class. So what's next? This number, right? 1/3, I times with 1/11, and I need to add it with what's on the top here. So I continue on the right side, in other words. So what are we going to get in this position on the top? Well, it's probably better to write separately. The negative 1/3 is on the top, right? And what I have to collect it with is again negative, because I have minus here. 1 times 1 on the top is still 1, but on the bottom will be 3 times 11, which is 33. Okay, we can put these two fractions together. Why not? We're gonna multiply it by 11 and the top and the bottom. Looks like with this tedious exercise, I'm not gonna have time to give you a quiz today. Well, at least you will enjoy some of this algebra of matrices. So it's negative 11 minus 1 is negative 12. Okay, negative 12 over 33. Should I keep it like that, or should I reduce it and put negative 3/11? Because 12 is 4 times 3, and this is 3 times 11, so it's 4/11. Sorry, should be careful. 4/11, right? And I divide by 3, you get 4 on the top and 11 on the bottom. Okay, so minus 4/11 produced here. See, it's a lot of work for each little entry. But the good thing is that we're moving towards the end a little by little. So now I need to keep on multiplying by that negative 1/11 in number 1. So it'll be just minus 1/11 collected with 0 on the top. So it'll be just minus 1/11. That's a little bit nicer. And then finally, 0 times anything is 0 collected with 0 above is just 0. So that's next place. And the same procedure I'm gonna have to do with the last row. How about that? Well, I guess we need to maybe clear this a little. So now my goal is 0 below that number 1. That's where I'm heading for. So let's quickly this mess here. Okay. So I already have what I need. I already have the 0 and that's the way to go. But now I need to actually decide how to produce what? 7/3 is there, right? So how to produce negative 7/3. That's how we get 0. So from 7/3 that we have on this position, I need to produce negative 7/3 and put it together. And looks like 1/11, right? If I put 11 on the bottom, that 11 on top will cancel. Well, you say, Alex, but you need 7 of them. Okay, so I put 7 11s, right? So again, if I multiply it, let me write it so you better see this. If I already have 7/3 to get negative 7/3 out of 11/3, I need to put 7 on the top and cancel that 11 on the bottom. So this is going to go away and get 7/3. So 7/11 is what I'm going to be using. So times by 0, and 0 will not change anything here, because again, multiplying by 0 is still 0, and adding with 0 is 0. So that first column will be preserved. All we care about is the last entry right now. So I'm multiplying by 7/11, right? 7/11. And collecting it with what's down below. And same thing I'm doing here, and same thing I'm doing here. So same thing I'm doing with each entry of my second row, and collect with what's below, because I'm paying the price. Say, Alex, that's a big price. Yeah, for that little 0 that we just had to get in here. But we'll be pretty much done after that, so no worries. So it looks like now I need to put these two numbers together, negative 7/3. You better do it separately. It's so easy to get mixed up if you start doing it in your mind. So I need to add it with 14/3 and see what I produce. And how do we add fractions? Well, there is only one way, same denominator. I need 11. So we got both of them 30/3, right? That's the point. So how many of those 30/3 will I get? Well, that one is minus 49. I say, what about that one? That looks like a big one. 140 and 14, that'll be 154. Please double check it in the calculator. It looks like 140. If I times by 10, another 1, so it'll be another 14, so it'll be 154. So I need to subtract 49 out of 154. So that'll be 105, looks like. Why is that 105? Because when I subtract 49, so like from 54, I subtract 49 is 5 and 100, so it's 105. And looks like I can divide this by 3, so I get some 11s. Because 105 is 3 times 35. Will be 35 11s. Please notice I don't want to pull out the whole part, because I'll keep working on these fractions again, so we'll keep enjoying. That's not it. There are 3 more. Well, the good thing is that the last 2 entries will be pretty straightforward. So let me clear maybe this a little bit. Because the last 2 entries will be not really much involved with fractions, so I can write them down to give you at least some pleasant feelings. Like here, 7/11 times 1 is 7/11, and added with 0 is still 7/11. So just did that one. And the very last one is going to stay as 1, because nothing changes here, because 7/11 times 1 is still, 7/11 times 0 is 0 plus 1 is still. But the question is, what's in here? Well, it's 7/11 that we multiplying by that 1/3, right? It's 1/3 sits here. And we add it with 1/3 on the bottom. Okay, let's give it same denominator, right? See, if you follow through this, you will definitely review your arithmetic pretty well and put together 7 and 11, which is going to be 18. And again, I can reduce this. Again, I can divide by 3, right? 18 is 3 times 6, so it'll be 6 11s. It's not bad. We little by little moving on, and we're getting closer and closer to our goal, which is here. Our goal is now to produce 2 zeros in my first column and 1 in the last. So I always start with producing a 1, and then we'll go up. Even though you don't have to go like that, but 1 will be definitely helpful. So where should I do this? Maybe above. Maybe I will go on the top, get some room up here. And that will be the last step. So just a little bit more pain and we'll be done. And that will be definitely a relief. So what I'm preparing here is again my matrix. And I copy first and the second columns just the way they are. And now my goal is to put 1 here and then bunch of zeros above. So how can this be done? Well, I need a reciprocal, as usual, remember, to produce 1 out of this, I need to take this row number 3 and multiply it by 11 on the top, 35 on the bottom. And that's what I'll be doing. And notice when I be multiplying zeros by those numbers, nothing's going to change. So what I care about, let me find some new color for this. I'll use 11 over 35. And the same thing I'll have to do here, as well as in the other two. Yep, 35ths and 11 35ths and 11. And that will give us this last row. So 2 zeros. Oops. Then 1 is produced because we cancel both of these guys, right? So that was the point of doing it. Now 11 and 11 are gonna cancel. So we have 6 over 35 in here. So we're gonna have 7 over 35 next to it. And finally, for the last will be 11 over 35 times 1 is the same 11. And the good thing is that we have produced the last row of our inverse matrix that we were actually trying to find. Was the inverse matrix? Well, it's little by little showing up on the right side. When we get those 2 zeros above 1, we'll get the entire thing. So in order to get there, I need to clear that previous step. What was in that position? It was 35, right? Yeah, 35. Better write it down so I don't forget. 35. It is very tedious. It is very tedious, and you definitely can do this on Monday after you had a good rest, right? So now what? Well, now my goal is to kill that 7 over 11. And to be able to do this, I need to subtract same 7 over 11 from it. Because this way, I will produce the 0 that I'm after. So from that position, from 35 11ths, I must maybe clean some room. So you better see this arithmetic stuff. But you will be an expert in arithmetic, which never hurts, right? After you follow through this, if you like, then 7 11ths, I have to subtract from it same 7 11ths. That's my goal because a 0 is what I'm producing. So how to get 7 11ths, not 10ths, 11ths out of that? Well, I need to, first of all, get rid of 35, right? I need to have it also negative. And in order to cancel 35s and get -7 on the top, because 35s go and I have -7 11ths. So what I do is I need to produce what? Multiply by -7 35ths. Actually, 7 35ths here, and the minus sign, of course, so it'll be subtracted. Well, and what do I have above? Well, above I'll have a 0 because that way it'll all cancel, right? So 35, 35 minus 7, I get 0. So when you say, why do you need that? Well, because I want to have to get the right side. We do this all because of the right side. So multiply by -7 35ths here as well. And then collect with what's above and put it in that area in the second row. 7 35ths. Okay. In fact, the last one will be nice because it's just -7 35ths times 1 with 0 above. It's -7 35ths. So that one will be just fine. But now the other two parts I'm going to have to struggle with a little bit. But there's no struggle. It's fun. So what I have here, -7 35ths, right? Times 6 11ths. Okay. And I need to collect it with -1 11th above. And again, all I need is same denominator, so I have to multiply by 35 here, as well as on the top. And get the result. So 11 times 35, 350, and 35, it's 385, I believe. Please double check. 350 and 35, 385. And what's here? -42. And -35 will be -77. Great. 77. There is a factor of 11 in it, right? Remember, it was 11 times 35 here, actually. So I can simplify this a little bit. I can cancel this. And say, Alex, that's minus and minus. Do you get minus? Yeah, I don't need to put another minus. So I cancel by 11. So on the top, I have 7. And on the bottom, I have 35. I say, Alex, you can cancel by 7 as well. So it'll be just -1/5. Yes. And that's how you start to get fun when you do lots of arithmetic. I love to cancel. So 7 35ths, it'll be -1/5. Ooh, interesting, right? So anyways, let me clean a little bit more room. So we'll be finishing up with this a little by little. So we have another fraction to deal with, these two, right? See what's coming out if I put -3 11ths together with this stuff, which is -7 times -7 is 49. And on the bottom is gonna be 35 times 11. Maybe I will be able to cancel, I suspect. That's why I better keep it as 35 times 11. And turn this into two fractions with the same denominators, right? So we keep following the same pattern, the same tedious pattern. So it's 105, right? With a minus sign. And I subtract these two. So we got 154. 154. That seemed to ring the bell. I saw 154 somewhere. Who knows where and when, but 140 and 14. Yeah, it factors with 11 as well. That's just amazing. Now we are having fun. Because notice this is 11 times 14, isn't it? 140 and yeah. So I can cancel this 11s and I can cancel also by 7. So it'll be minus 2 on the top and 5 on the bottom. How about that? It's canceled. And we're almost there. Just one more row. Are you ready for one more row? Because my goal is that last 0. My goal is to now kill 18/33. Yes, Alex, this is actually divisible by 3, so it's 6 11s. Oh, maybe I better rewrite this as a 6 on the top and 11 on the bottom, isn't it? Because that's what 18/33 actually stands for. You want to keep it simple, of course. Just 6 11s here. Notice I just simplified, nothing changed. And my goal is to subtract from these 6 11s the same exact 6 11s. And that's what I'm going to be working on with the lower number. So my goal is to get 6 11s and to subtract from it 6 over 11. And the question is, how can I produce it out of what we have here on the bottom? Out of, let me clean the bottom part because we don't need it anymore. Out of this 35 11s, right? So what I was multiplying it by this. Just want to make sure I don't get mixed up at the end, because that'd be disappointing. So it's 35 11. So how can I produce 6 11s out of it? Well, the 35 11s, 6 11s need to be multiplied by negative. And since it's 35 11s, I need to kill that 35. Right? And have on the top number 6. So notice that if I use this 6/35, right? So if I times by 6/35, I will achieve my goal. So I will get actually 6 11s. And when I subtract it, then everything will be fine. So negative 6 over 35. Negative 6 over 35 is what I'm multiplying by my third row, just to keep track of what we do is third equation we're working with. And then I put it together with the number here because of that 0. So again, negative 6 on the top, 35 is on the bottom. How about that? Again, we kill 35s and we get minus 6 11s. So together with this 6 11s, we'll get what we need, 0. And of course, the point of story is to produce these numbers and we'll be done. That'd be a good news. So 6 over 35 will be multiplied also here, as well as there, as well as by number 1. Well, times 1 is my favorite. So right away I can put negative 6/35 here. So it'll be at least something a little bit more fun. So -6 over 35. So that's the last product, 6/35 times 1 plus 0 is just 6/35. Okay, so what's the others though? Well, I definitely want a room. So let's use this. So 2 more numbers to add and we'll be done. That's a very good news, isn't it? So I'm going to here with a product of -6, right, 6/11, -6/35, and I put it with whatever is on the top, and on top is this -4/11. 11s, that's great. So I need another 35 because again, we always need the same denominators, right? When we deal with fractions. So I'll keep that 11 times 35 for now. Maybe I'll cancel and see what's here. -36. And then 35 times 4. 120 and 20, 140. Isn't it? Double check, 120 and 20, 140. So it'll be -176. 176. Is that 16 times 11? I think so. 160 and 16, yeah, 176. See, that tells me that we are on the right track, because if we start to produce very crazy numbers, that would probably be not right. But we canceled 11. It's 16, so nothing I can do, just leave it as a -16 over 35. 16 I can only divide by 2, but that's fine. We at least cancel 11, that's a big one. So 16/35 is here. See, that's inverse matrix. What we are producing here is that inverse matrix. Just one last spot and we'll be done. You ready? That was pretty tedious. And that's why I don't ask my students to ever do this exercises, because it's really a lot. But if you're planning to become a math major or engineering major, you will be dealing with numbers, with fractions, and that's something that you should not panic about. So -16/35. So now I go upwards and I multiply in these two numbers and add them with what's on the top. Oh, what was on the top? I think I accidentally erased a part of the fraction that I needed. So what was there? Anyways, you could probably recover it if you just look at the recording of this lecture and have this fraction -1 over what? Add it with -6/35. Yes, we're pretty much done. Times this 7 over 11, right? 7 over 11. And that negative will be -1 over what? The question is, what was in here just a little while ago? If you'll be able to look at the recording and scroll it back a little bit, you will definitely see this, right? But I don't have it. Somehow it's disappeared. That's pretty odd, huh? Well, anyways, I'll let you finish with this. So whatever was here, where it was -2/5, but I produced something out of it. So whatever is here needs to be added, and I somehow accidentally erased denominator. So when you add, you will put it on the top here. So that'd be your last number. And that will give you the inverse matrix out of these nasty fractions. Actually, fractions are not nasty, they're good. They're my little friends, right? So anyways, I guess it's a good time to stop and for you to relax, and you deserve that, right? It's been quite interesting procedure. And that's what I can say about pretty much all exercises in linear algebra. They're tedious. When you start working with matrices, it is time consuming. And the last thing I want to tell that I will put lectures, recordings of lectures on the YouTube. I already working on it, and everything we need up to date. Today's lecture maybe not, because it's not needed for the midterm. It's a little bit too much, but I will eventually do that. So by Wednesday, they should appear on the YouTube. So everything be in one place. There are 10 lectures we had so far with a new material. So you will get them all on the YouTube in one place. So I will share the link to that folder with you on Wednesday.
Very nice.
You're welcome. Thank you for handling all that, and I'm gonna stop for today, and there's no time for a quiz, so maybe we'll have one next time. We'll see how.